The campaign for Soyuz Flight 9 began June 5th with preparation of the upper frigate stage in the integration building called the MEEC. Operations also started in the S-3B building for filling of its fuel tanks. Parts of the first, second, and third stages, or tri-stage, were transferred to the MEEC starting on July 9th, and here they were assembled on the 21st. The two Galileo satellites, 5 and 6, arrived in French Guiana May 7th to begin their preparations. These two satellites were transferred to the S-5 building on July 28th, where their fuel tanks were filled with propellant. The twin satellites were then integrated on their adapter or dispenser, August 7th. This adapter is used for launches of multiple payloads and is designed particularly for constellations like Galileo. The satellite and launch teams met daily during this period to ensure all was proceeding on schedule. The satellites were transferred on August 13th to the S-3B building to receive their mechanical springs used for separation, and here they were put in place on the frigate upper stage. They were then covered by the fairing the following day. On August 18th, the launcher was transferred from the MEEC to the launch zone, where it was hoisted into its vertical position on the launch table. That evening, the upper composite, consisting of the frigate, the two Galileo satellites, and the fairing, was moved from the S-3B building to the launch zone and integrated atop the launcher. Two full dress rehearsals of the launch with the vehicle and the teams at the space base took place 2 days before launch and the day before launch. Finally, the Launch Readiness Review meeting on August 20th gave the green light for today's mission to begin. Joshua Jampel back with Sylvain Lodo. We are focusing on the launcher during this initial part of the broadcast. We'll turn to the satellites later on once Soyuz has left the pad. Some other launcher preparations, because this countdown began a long time ago, some other ones that have already taken place, Sylvain?
Yes, at minus 430, we filled the tanks with hydrogen peroxide. This took 20 minutes. At minus 310, we filled the tanks with liquid oxygen, and this took 45 minutes. And then at minus 255, we filled the tanks with a kerosene. All these different fuels are used on the Soyuz vehicle.
Up in the Soyuz Launch Operations Center, the operations manager on the Russian side is going to be very shortly turning the key to start. There's something done by hand. This is what it looks like up there at the Launch Control Center. There's an actual key which is turned to get the system going. They call it in Russian Kluchna start. Sorry for the pronunciation, but that's the beginning of the automatic sequence. This launch center lies a kilometer from the pad. It's inside a 2-story bunker made of reinforced concrete. The roof is lined with 2 meters of it to protect the teams working inside.
Yeah, and inside, the European team is led by the COEL. Tonight it's Bruno Mas. He's the interface between the manager of the Russian team and the Jupiter control building.
And the Russian operations chief here today, Alexander Shcherevan, you saw him, working alongside representatives of the main Russian firms participating in this joint European-Russian program, which is Soyuz. In all, about 100 people up there, right?
Yeah, in all over 100 people, and hard at work at this moment.
About an hour ago, the gantry was moved back around 80 meters, revealing the launch vehicle. Our Soyuz pad is the 7th and most recent. We're going to go next to a brief description of the mission today. Once we lift off, Sylvain, basically tell us what happens.
Yeah, so the powered phase of Soyuz, first 3 stages, lasts about 9 minutes. Then the upper composite, called the frigate upper stage, the 2 Galileo satellites, will be separated. And the 3 lower stages then will fall back into the ocean.
The frigate, which you see there, being separated from the 3rd stage, will carry out 2 powered flight phases. There will be 2 burns. After the first burn, the upper composite is spun during what we call a ballistics phase. We'll explain all that later on. That lasts about 3 hours and a quarter. Then the engine ignites a second time for a 5-minute burn, which takes the Soyuz to its separation orbit for the satellites. They'll be released at about 3 hours and 47 minutes after liftoff.
Yeah, the series of ground stations follow the launcher during all the phases to pick up the radar and telemetry.
Some basic Soyuz facts: over 825 launches. I think it's 800,827, a world record. She also set up, as you may recall, the first artificial satellite Sputnik in 1957, and the first man in space, Yuri Gagarin, 1961.
Yeah, the first woman in space, the first spacewalk. She also the world's highest demonstrated reliability record, so it's close to 99%.
You heard the DDO call out that the electrical umbilicals on the satellites have been released. They drop into a metal basket designed for this purpose. 2 minutes to go. Final countdown leads to ignition simultaneously of the central core stage, the second stage, and the boosters at the same time, followed 20 seconds later by liftoff. We want to give you an idea of the ignition sequence. It's a little different from Ariane's, if you are familiar with Ariane 5. 20 engines are lit at once. The sequence begins at minus 45 seconds with the gantry withdrawal, and you should be able to see that on the screen. Then at minus 40 seconds, Soyuz is autonomous. Power has passed from the ground to the onboard computers.
Yeah, and then at minus 38 seconds, the third stage umbilicals are released, so they fall in a second basket like those for the satellites.
Then at minus 35 seconds, the arms will open. You should see that, and the DDO will call out that milestone. They retract from the launcher.
Yeah, then the ignition sequence begins at minus 25 seconds.
The DDO is going to call out the 1 minute mark, and we'll be into the final 60 seconds.
Top. H0 moins 1 minute.
And there we are. Now, continue with the ignition sequence. It begins at minus 25 seconds, you said, then at
at minus 20 seconds, the first stage engines are ignited, and the second stage single engine is lit at the same time.
Now, the ignition sequence is in 3 stages. From minus 17 to minus 6 seconds, the engines are tested automatically. At minus 15 seconds is the first controlled ignition at about 20%. There's the gantry pulling back. That's always an exciting. That means we're on our way. At minus 7 seconds is the second intermediate pressure, 50%. And then minus 3 seconds, the order is given for the final phase. Full throttle.
Top. H0 moins 20 secondes.
So watch for that.
Largage du mât.
We'll let you watch the final countdown. We'll be back. Enjoy the liftoff, everybody.
Attention pour le décompte final. 7, 6, 5, 4, 3, 2, 1. Top. Décollage. Les paramètres de lanceur sont nominaux.
So, Soyuz, you saw lifting off perfectly from French Guiana, beginning her 9th mission from the spaceport. It's always impressive, no matter how many times you see Soyuz powering into the sky, today the blue sky over French Guiana. What went through your mind as you watched liftoff? Because you've seen her liftoff before.
No, I think you're right. I saw it already from Baikonur, but this time is also very special. And different it's with daylight.
Because in Baikonur you saw it
during the
night
flight.
Yes. Yeah. And in the snow, I imagine.
No, it was during another season.
336 tons at liftoff. That's half the mass, roughly, of an Ariane 5.
Yeah, the boosters and the central core, or the second stage, are burning now.
And you can see them as Soyuz heads north up the Atlantic coast and then eventually east. Boosters weighing 45 tons at liftoff?
Yeah, total mass of the first stage is 178 tons. The engines run on liquid oxygen and kerosene, the same propellants which are used in each of the 3 lower stages.
Remember, Soyuz weighed 336 tons at liftoff. The boosters will be separated in just about 5 seconds. We're waiting for the DDO to confirm that report, and we'll be able to see it. There's the flame out, and there's the separation. Beautiful. You see the 4 boosters falling away from the mothership. The second stage continues to burn. Now, from 336 tons at liftoff, with the boosters gone, how much does she weigh?
I think we are having 135 tons. So in less than 2 minutes, she loses more than half her weight.
On the bottom of the screen, you can see on the left our altitude and distance and speed. The altitude on the left, approaching 70 kilometers. We're going to separate the satellites roughly around 23,000 kilometers, so be watching for that. Now, the figures on altitude and speed are coming in from the downrange stations, and they're received by the Russian teams in the launch center, where we were just a moment ago, and then they're confirmed before being broadcast. The downrange stations for our system are here in Kourou. There's one called Galileo. It's behind us in Jupiter. The Soyuz signal will next be picked up by a naval station, which is actually a ship out in the Atlantic, right? And then by Santa Maria in the Azores.
Yeah, you're right. It flies. Soyuz flies first to the north and then to the east over Europe.
And over Europe, she's picked up in the south by the station near Toulouse, which is called Osagel.
Yeah,
Am I saying
that's
that
right.
Then she continues east and south and is finally picked up by Perth, which will see separation of the 2 Galileo satellites over Australia. Now, Galileo has her own stations. These are the Arianespace stations.
Exactly. This is linked to the launcher, so we're having other stations either for the LEOP, when we take the satellites after separation, and also then, of course, in the Galileo system, you have other stations. But this will be addressed later in the video transmission.
When we have some time, right. We're coming up on jettisoning of the fairing. Now, the DDUs just called that out. You see what happens there. This is a camera not on board tonight. It was on board previous flight, but it's the same system. The 2 halves of the fairing are actually blown away. There's a controlled explosion. And once they're gone, they reveal the 2 satellites. You can see them there. Side by side, we no longer need the protection of the fairing because why? We're out of the Earth's atmosphere?
No, now we are out of the dense layers of the atmosphere, so over 100 kilometers. And here there's neither friction nor heating. So we discard any dead weight and as soon as possible to maximize the launcher's functional operation.
We're not a lot of dead weight in the space business. As soon as something is done with, we let it go. We're coming up next in about 10 seconds on ignition of the 3rd stage and separation of the 2nd stage. And once again, you'll hear the DDO, the Range Operations Manager, calling out confirmation of that information, which again comes into him from the posts, the outposts all across the space base here, which are monitoring the launcher and the satellites and everything else.
Séparation du bloc A.
There we are. Separation of Block A, it's called. It's another terminology for the 2nd stage. Ignition of the 3rd stage. One particularity of the Soyuz, that's the skirt being jettisoned. I'll get to that in a minute. With Ariane, we separate the lower stage before igniting the upper stage. Soyuz does the opposite. The 3rd stage is ignited 2 seconds before separation of the lower stage. Here's a replay of the launch about 5 minutes ago, which you can relive those exciting moments. Soyuz rising into the sky a little more quickly than Ariane does, because she's a little lighter.
Correct.
3rd stage skirt, as we mentioned, is separated 10 seconds after the ignition of the 3rd stage. What you see there on the left was the engine and the 3rd stage burning, and on top of that was the frigate. There's another replay from another angle. We have a lot of cameras across the space base, and we'll have even more for you towards the end of the broadcast. We'll be back with more of the mission in a moment, but first the latest news from Arianespace. July 29th, the launch of Arianespace Flight 219 made it 60 straight successes for Ariane 5. On board the 5th ATV, or Automated Transfer Vehicle, called Georges Lemaitre, the cargo ship which brought supplies to the International Space Station. And on August 12th, the ATV docked with the station, bringing food, water, fuel, equipment, onboard experiments, and gifts for the astronauts. The ATV also helps boost and keep the station on its orbit at 450 kilometers above the Earth. Gaia began her mission last December 19th on board Soyuz Flight 6. After onboard validation, the satellite, 1.5 million kilometers away from Earth, is now ready to begin her mission, mapping the Milky Way's billions of stars. On August 6th, after a 10-year voyage of 6.5 billion kilometers, Europe's Rosetta probe went into orbit around the comet 67P Churyumov-Gerasimenko. The 3-ton satellite was launched by an Ariane 5 in March of 2004. Back on Earth, August 12th saw transfer of the vehicle for Ariane Flight 218 from the integration building to the assembly building. Its 2 satellites are Measat B for Malaysia and Optus 10 for Australia. And the campaign for Ariane Flight 220 has begun with integration of the 3 lower stages. Flight 220, set for October, will orbit another 2 satellites, ISDLA-1 for Intelsat and ARSAT-1 for Argentina. On July 17th, ESA and Arianespace signed the contract for launch of the second radar satellite Sentinel-1B. The satellite is part of the Copernicus program jointly run by ESA and the European Union. Eutelsat brought its fleet of satellites to 37 with signature of the contract with Airbus Defence and Space and with Arianespace on July 31st. Eutelsat 172B, the first all-electric satellite, will be launched by an Ariane 5 in 2017. On August 20th at the CSG, Arianespace and ESA signed for 3 launch services with the Ariane 5 ES. With the new contract, 12 Galileo FOC, or fully operational capacity satellites, will be orbited starting next year, each launcher carrying 4.
So we are coming up on extension of the 3rd stage.
You may have noticed that since the start of the mission, events are announced by the DDO, not always, but sometimes with a slight delay of a few seconds. This is quite normal. The information, the telemetry and the radar coming in to the ground stations, then sent by them here to Jupiter, they have to be first confirmed by the Russian teams in Moscow. So this delays a little bit of a lag, just a couple of seconds. They then come to French Guiana at the CVI, which is the Immediate Visual Control Center, where we're going to go in a couple of minutes. And the CVI relays them to the DDO here in Jupiter, and the DDO confirms them. Coming up on separation of the 3rd stage, which is still burning, another 2 seconds. There it is, a 3rd stage on the left there, being separated. The first 3 stages have done their work. Now only the Frigate upper stage is functioning. Now tell us about the Frigate.
So Frigate is an autonomous, flexible upper stage. So it's a relatively recent addition, which was qualified in 2000. It's an autonomous and flexible stage designed to operate as an orbiter. It extends the capability of the Soyuz vehicle, giving it access to a full range of orbits. And it's independent from the lower 3 stages. Since Frigate has its own navigation, guidance, attitude control, tracking, telemetry systems.
Completely independent then, as an independent orbiter, as you said. If the 1st, 2nd, and 3rd stages are Russian of the Soyuz, the Frigate upper stage is European. The payload, the whole payload, is actually the entire upper stage and the satellites together, right?
Yes, together. This is correct, yes. So Frigate's engine uses storable propellants, and it can be restarted up to roughly 20 times, which means it can be used for complex and precise missions, like ours today.
Like today's, right. The DDO has confirmed, you heard him, the ignition of the first Frigate burn.
Yeah, the Frigate upper stage is produced by NPO Lavochkin, and it has a mass at liftoff of about 6.3 tons.
This first burn will last 13 minutes and 8 seconds. And the second burn later on will take place in about 3.5 hours and last about half the time, only about 5 minutes. You're watching Arianespace's launch of the 9th Soyuz from French Guiana. All is well on board. We mentioned the deployment of the 30 Galileo satellites will take place over several different phases. We're opening now what they call the FOC phase, fully operational capability. And in our next film, you can see how this has been accomplished. There's a certain Sylvain Lodo being interviewed. See if you recognize him.
Hope so.
The Galileo program, in which ESA and the European Commission are working together to develop and build the first publicly owned and operated satellite navigation system in the world, has entered a new phase in its development. At the end of 2013, Galileo successfully completed its in-orbit validation, or IOV. During this phase, the European Space Agency ESA did extensive testing of the system using a mini-constellation of 4 satellites. The satellite signals were validated in laboratories and in the field, driving around remote locations, at sea and even in the air. The results were beyond expectations.
After the IOV phase that we have completed the end of last year, we are now in the so-called deployment completion phase, which will go up to end of 2016. And after that, we will enter into the so-called exploitation phase.
During this deployment phase, Europe is procuring another 22 satellites. Together with the 4 satellites already launched, the target is to have a constellation of 16 satellites by the end of 2016. The addition of these satellites will increase Galileo's performance in terms of positioning, accuracy and service availability. The ultimate program objective is to deploy a 30-satellite constellation for the overall system. However, the provision of improved navigation services is also dependent on the upgrade of the ground segment, which will need to be expanded accordingly.
The Galileo ground segment is made of control centers, which are located in Germany and in Italy, and a number of remote stations, which are necessary for the control of the satellites, for the uplink of the messages, or for collecting the data coming from the satellites. So currently we are having a number of ground stations which are already deployed, and the purpose of the phase in which we are is to increase the number of stations to get to the final numbers that we need to get the full performance. The distribution of remote stations is worldwide. We need in particular to have stations in high latitudes to be able to communicate with the satellites frequently, and also to have stations which are around the equator where we have less contacts but longer ones.
The Galileo satellites are controlled in space from 2 centers, one in Oberpfaffenhofen, Germany, and one in Fucino, Italy. This is where the navigation message is generated and uplinked to the satellites via the remote stations. The satellites then broadcast the navigation signals, including the latest message prepared by the ground segment. As part of the deployment phase, both centers are being upgraded so they can act as a backup for each other. With the successful in-orbit validation phase and the ongoing deployment phase, with the launch of the next 2 Galileo satellites this summer, Europe's Galileo program is well on its way. But new challenges still await ESA.
Now that we have demonstrated with the IOV phase that the performance of the system will be met, the main challenges of Galileo is to make the system robust, extremely stable, and operable in an easy way in order to minimize the costs.
With the deployment phase underway, ESA and the European Union are taking another step forwards in completing the Galileo constellation and offering navigation services to the users.
All right, all is proceeding normally on board. Some words on Galileo's space segment. Now, what do we mean exactly by space segment? We talked briefly about it earlier, but I'm sure you have more to say.
Of course. So by the space segment, so as opposed to the ground segment, we talk about the 30 satellites. And these satellites are placed in 3 different circular orbits. The altitude in the end will be 23,222 kilometers exactly.
And our next film will explain a little more on how the Galileo system works.
The payloads of the satellites have much the same design as those tested with the Jovi satellites, with advanced technology systems such as the atomic clocks and the navigation antenna. For a satellite navigation system to work, a receiver on Earth needs to simultaneously receive the signals of 4 satellites. They circle the Earth at 23,000 kilometers in 3 orbital planes. The receiver computes its own position by calculating the difference in the received signals from the satellites that will be in its visibility. But the Galileo system is, in fact, one vast space clock. The signals broadcast by the spacecraft must be rigorously synchronous, timed by identical clocks. Each spacecraft has 4 atomic clocks. They work like conventional ones, but their time base, instead of an oscillating mass as in a pendulum clock, use the movement of atoms, their property to switch rapidly between different states of energy. It is the frequency of this transition that is fed into a counter. Each IOV spacecraft has 2 types of clocks. The so-called passive hydrogen maser is the most precise clock ever placed in orbit for navigation, accurate to 1 second in 3 million years. Its backup is a rubidium clock, accurate to 3 seconds in 1 million years. The master clock's timing precision is critical to achieve the accuracy of the Galileo service. An error of a single nanosecond, that is 1/1000th of a second, implies a ranging error on the ground of 30 centimeters. If translated to a second, this represents an error of 300,000 kilometers. Instead of being in one's car on the way home, one might as well be on the moon. To achieve this extreme time stability, the satellite's operating conditions and its environment are also paramount. So the satellites have been designed to maintain constant operating conditions. Temperature variation is limited to 1/10th of a degree, which is a remarkable feat considering that the spacecraft pass regularly from sunlight plus 100 degrees Celsius to shadow minus 150. The Galileo system must also take into account the space environment, such as radiation level, that changes along the orbits that the satellites follow, with resulting slight variations in the propagation time of their signals. Finally, there is the ground segment. The tracking stations around the world and the 2 control centers in Germany and Italy must equally beat like metronomes, rigorously in step with the satellites, capable of predicting their precise position and timely contacting them to upload freshly computed navigation correction instructions. It is the combination of all these elements that will allow Galileo to provide precise and guaranteed positioning services.
There's a little more info on the system. Anything to add on the ground segment that wasn't mentioned in the film?
Yeah, maybe we can go a bit beyond what we said before. So yes. The current versions of the control segment and the mission segment are being used today for every day, in fact, for the routine operations with the first 4 operational satellites, the one from the in-orbit validation phase. And so these versions are being upgraded to increase availability and redundancy and operability. So availability is through the redundancies, because we would like to be able to switch over from one side to another and so on.
Good. So the range of services offered by Galileo are the subject of our next film. Back with more in a minute.
The modern world relies on precision and time. Pilots must know their exact position, altitude and speed when flying aircraft. And simply driving from A to B benefits from satellite navigation. Navigation depends on timing, and Galileo, Europe's first global satellite navigation system, will offer unprecedented accuracy, pinpointing locations to within 1 metre. With it, Europe will master its own civilian system, rather than depending on GPS, controlled by the US military. To ensure this feat, each Galileo satellite contains 4 atomic clocks, one of which, the passive hydrogen maser clock, is accurate to within 1 second in 3 million years. And whether it's calculating the most fuel-efficient routes, tracking shipments, or helping reduce the amount of pesticides with precision farming, Galileo has been designed to provide a variety of services.
The most important one, of course, and the one that will be delivered first, is the open service. This is for the open public, for the mass market. We will have also with Galileo other services of added value, like the commercial service, that will allow us to improve the accuracy and the reliability of the signal. And this will be used for professional applications to obtain better accuracy on ground. But we also have the public regulated service. This is a specific service of Galileo, intended for government use, very robust and with very good performance.
The latest satellites are the final pair in Galileo's in-orbit validation phase. They contain a new search and rescue antenna and payload, as will all future Galileo satellites. This service will retransmit an emergency signal coming from a beacon on a boat or an aircraft to a rescue control centre, contributing to the international COSPAR SARSAT search and rescue detection system. When complete, Galileo will consist of 30 satellites orbiting the Earth. This global constellation will also support Galileo's smaller precursor, EGNOS, the European Geostationary Navigation Overlay Service, currently based on filtering GPS signals and offering what is called the Safety of Life service. Aircraft already carry receivers using EGNOS and take advantage of space-based navigation for guidance during landing. With Galileo, the system will be redundant, and the pilot will have access to 2 satellite signals, removing the sole reliance on one single system. Galileo will give Europe independence for satellite navigation services, an important growth area for social and economic activities in Europe and beyond.
Now, Sylvain, the film mentioned EGNOS and the Safety of Life service. Can you explain those a little bit, please?
Yes, of course. So EGNOS was developed to provide accurate and guaranteed guidance to aircraft, or all types of aircraft, for en route phases, but also for precision landing, in particular for the medium-sized or small airports in Europe. So this is done through providing augmentation to GPS signals. So it increases the accuracy and it provides what we call an integrity information to use them. Use, don't use, these kind of things.
So we can call it a precursor of Galileo?
In a way, yes, because the technologies are very similar, yeah.
The Galileo system is important, we mentioned, because it'll guarantee autonomy for the European Union vis-à-vis, as was mentioned, the US and Russian systems in this highly strategic field, which includes, of course, military applications. In just a few moments, we should be hearing from the DDO, who will announce confirmation of the extinction of the first frigate burn. Remember, because the slight delay with the information coming in here, this was due to happen. You see on the animation there, the engine has shut down. So we can assume that the first burn is over. What's happening now is we're going to coast for about 3 hours and a quarter and then reignite the engine for the second burn. This is called the ballistic phase.
Yeah, the second burn is set for roughly 3 hours and 38 minutes.
Du moteur Frigate.
And there's the DDO calling out the confirmation. Exactly. So we had a little more delay this time.
Yeah.
You said roughly 3 hours and 38 minutes.
Well,
it's exactly 33 hours, 33 minutes and 35 seconds.
Yeah.
More on Galileo's application in our next film.
Galileo is on its way, but satellite navigation in Europe is already a reality thanks to EGNOS. By using 3 geostationary satellites and a vast network of ground stations, EGNOS sharpens and secures the accuracy of American GPS signals across Europe with a precision down to the meter. Advantages on Europe's roads will cover much more than in-car navigation. Road haulage companies and bus operators will be better able to manage their fleets of lorries or coaches, optimizing movements, avoiding congestion and saving fuel. Galileo will introduce new ways of monitoring tachychronograph systems, thus increasing safety and also tracking stolen vehicles. Likewise, Galileo will assist maritime transport. With an estimated 50,000 ships around the world, it can contribute to safer and more precise navigation. Complementing and improving the existing COSPAS SARSAT system, its search and rescue service will detect activated distress beacons, notifying the appropriate rescue services and letting the users know that help is coming. Agriculture will benefit in the field of precision farming. 60% of satellite-guided tractors are already using EGNOS, reducing driver fatigue, allowing ultra-precise tillage or distribution of fertilizers and herbicides, and livestock can be monitored at a distance. Various categories of citizens will be able to use individual handsets or mobile phones that incorporate Galileo chips, guiding tourists in an unknown city, providing real-time information on local public transport, or helping the blind or poorly sighted and assisting the disabled. Even if Galileo will be the first civilian global navigation system in the world, the use of certain so-called public regulated services will be restricted to authorized users such as governments for sensitive applications that require a high degree of continuity and reliability.
Now, Sylvain, the film mentioned precision farming. Now, you wouldn't normally think, well, I wouldn't normally think of applications for agriculture, but there they are. Galileo offers them.
Yeah, you're right. Precision farming is a good example of a typical niche application that you can develop when you're having a good positioning system. And this is the case for EGNOS or Galileo.
And search and rescue, you would, I think, normally think of SAR.
Yes, it's an important contribution from Galileo to search and rescue. So in addition to the payloads, which we are embarking, we're having a ground segment. This is the third ground segment we're having on Galileo, which was developed in a way which is not usual for this kind of applications, because we are coordinating the use of 3 stations on the ground to detect and locate distress signals. And normally it comes from a single station.
The satellites were built by Bremen by OHB Systems, and our next film will tell you all about the prime contractor. We want also to mention our friends at Surrey Satellites Technology, SSTL in the UK, who provided part of the payload. OHB, Otto Hydraulic Bremen, the company has belonged to the Fuchs family since 1981, I believe. OHB prime contractor for the Galileo FOC, the fully operational capacity satellites. Today's Arianespace's first launch for them. There's one nice note we'd like to mention. OHB's founder, Manfred Fuchs, died last April, and a commemorative plaque was placed on the satellite Galileo 5 in his honor. So his memory went up in space today along with one of his satellites. This is a new family. Sylvain, you were telling me, compared to the IOV, the in-orbit validation
fleet? Yeah, correct. The platform has gone through a specific development.
All right, we'll get back to that. The project is managed jointly, as you know, by ESA and the European Union. A look now at the European Commission.
Ladies and gentlemen, today's launch of 2 new Galileo satellites from Kourou in French Guiana is another milestone in the history of the program. 4 satellites are already in orbit and the system's operation has been validated. The 2 additional satellites, based on a new design, are the first of a new phase leading to the full deployment of the constellation. These 2 satellites are also the first that the EU fully owns. This strengthens the EU's position in the space domain. I would like to thank the EU space industry, OHB and Arianespace, as well as the European Space Agency and my services in the European Commission for today's achievement. Difficulties had to be overcome. This may happen in large-scale programs. What matters is our collective capacity and determination to solve problems that may arise, and this capacity and determination have been proven. With 2 additional satellites in orbit, Galileo is moving closer to the provision of early services in the course of next year. This will be to the benefit of EU companies, international partners, and also European citizens. A second launch is planned in 2014, and in 2015 additional satellites will be placed in orbit. The EU space programs are strategic for our technological and scientific competitiveness. This is why the EU has decided to invest 12 billion euro in space activities over the period 2014-2020. And this is also why the Commission recently invested 500 million euro to secure the use of 3 European Ariane 5 launchers for the future Galileo satellites. A good news for the autonomous access of Europe to space. Today, the EU is turning our huge investment in space into concrete results. I am convinced that we are moving forward in the right direction.
Forward in the right direction concerns the future of Galileo, of course. We started talking about it briefly in our interview before we came up here in the booth. What exactly is coming up in the 2nd generation? Because ESA engineers are already hard at work on it, aren't they?
Correct. So since several years, there have been an important set of studies that have been launched by ESA to address key topics for potential evolution for the next generation. So, for instance, there are topics like increasing the power of the spacecraft, implementing inter-satellite links, using electric propulsion, and there would be also some important system-level optimizations, for instance, to resist better against cyber-security threats, or to improve the signals, for instance.
Okay. All is okay on board. Didier Favre, Director of ESA's Navigation Department, will tell us now all about that future, Sylvain, in our next film.
The Galileo satellite's navigation program is ready to make yet another leap forward. After the completion of the in-orbit validation of the Galileo system at the end of 2013, ESA and the European Union are now ready for the deployment phase. It starts with the launch of 2 more satellites this summer from French Guiana. More will follow until the completion of the Galileo constellation, which will eventually consist of 30 satellites. To accomplish this, ESA will accelerate production of the remaining satellites with the aim of launching them at a rate of 1 launch every 3 to 4 months.
To do it, we have initiated 2 sets of new elements. One, we have 3 sites where satellites are under preparation. One in Bremen, where satellites are built. One in Estec, in Netherlands, where satellites are tested before they are shipped to Kourou. And one in Kourou, where they suffer the last preparation before the launch.
These satellites are needed to make the system reliable and robust in order to deliver the services. Early services are expected in 2015. However, satellite navigation programs in Europe are not limited to Galileo. There is also the EGNOS program, operational since 2011, that contributes to air traffic management. This service, now used by aircraft, improves GPS data and informs the user on the reliability of the data.
EGNOS is extremely good in terms of performances. The decision now with some civil aviation in Europe is to use EGNOS as a primary system, meaning that they could dismantle other systems and to rely more on EGNOS, which is of course a demonstration that EGNOS is working well.
Soon EGNOS will not only augment GPS but also Galileo. While this first generation of Galileo satellites are being deployed, ESA is preparing the second generation to be deployed around 2022, when the first generation will be retired.
It's quite difficult to build a satellite, it takes years, and we have now to define what will be the shape, the size of those satellites to be launched in 8-9 years from now. And we have now to prepare this future, both for satellite and for ground segment. We don't know yet what will be the Galileo second generation, but we know already what are the elements we have to improve or we intend to improve. Mainly, of course, performances, because the other systems are improving every day, and we have to be comparable to the best in the world. That's evident.
With the Galileo program, Europe is building the first civilian navigation system in the world. A system that will need to evolve to ensure improved services to respond to the changing requirements of the users.
Okay, we're back now, so to keep on the second generation. So the transition to this second generation will have to be well coordinated because we are having an effective lifetime of the Galileo first generation, which is linked to the lifetime of satellites. Those satellites are normally having a lifetime of at least 12 years.
Yeah.
So it means that as Galileo is an operational system, there will be an important legacy to transition from this, in particular if it works well. So it means this transition will be in any case progressive.
Things are progressing here too at the space base. There is a new building for filling Frigate with her propellants to make operations easier and to shorten the Soyuz campaigns, which can be a little long and involved. They want to get them down to fewer weeks, I think. This was one of the things the French Minister for Research heard about from the authorities here on her recent visit to the space base last month. Geneviève Fioraso, France's Minister for Higher Learning and Research, visited French Guiana between July 27th and the 30th. She met with local authorities and with partners involved in Europe's space program, the European Space Agency, CNES, Airbus Defence and Space, and Arianespace. Led by Stéphane Israel, the Arianespace teams showed her the launch facilities, including the Launch Management Center and the Integration Building, where she met the technical staff and also got a look at the Ariane 5 launcher being readied for its September mission. The minister had these words after a successful launch of the ATV-5.
The launch we have just witnessed has a specific value. Indeed, it is the 60th successful Ariane 5 launch in a row, the 74th altogether, and the 5th and last launch of an ATV. Let me first, on behalf of the French government, pay tribute to the women and men, scientists, engineers, technicians, administrative staff at all levels who contributed to that wonderful success. I want to pay tribute to the culture of cooperation which enabled the success of the ATV, involving 3 space agencies, industry, teams of different cultures, from public and private sectors alike, working towards a common goal, an exceptional goal. That success left nothing to chance. It is the result of a deliberate, long-lasting national public space policy, immediately European and international. Each Ariane launch reminds us that independent access to space is a strategic stake. It is first and foremost a sovereignty stake. It is also a major scientific, technological, industrial and commercial stake. Upon this Ariane 5 launch from this impressive Kourou base, I'd like to comment on the future of European launches. Today, Ariane is the cornerstone of our sovereignty for access to space, one of the pillars of development in the European space sector. Ariane orbited over half of the commercial satellites operating today. We can legitimately be proud of that, but in that field, as in others, we must not rest on our laurels. International competition drives us to make drastic and clear choices to stay ahead. That's why, after the ministers approved Ariane 6 at the Naples ESA meeting, end of 2012, I have wished to gather all the national players of the sector, agency, operator, industry, main customers to work towards a common approach so as to anticipate on the difficulties of an even fiercer international competition. Thanks to everyone's efforts, we have recently come a big step forward as the President of the Republic underscored a month ago at the Élysée Palace, welcoming the agreement between Airbus and Safran on a joint venture on launches to be operational at the end of 2014. I also want to pay tribute to the leadership of ESA and CNES for all the preparation work before the ministerial meeting of December 2014 along the lines of thought that brought industry to take that decisive step. We trust that this process will be completed by September, time frame in which an informal ministerial state meeting will enable us to come to an agreement next December at the ESA ministerial meeting in Luxembourg. And I want to say today that Ariane 6 is an ambitious and indispensable project to prepare for a sound future of the European space launcher sector. That objective, obviously shared by all, is my absolute priority and that of the French government, which wants to maintain a strong and successful French space team and support it as a European champion and world leader. Against a budget-constrained environment, the financial effort of the government will not yield. France devoted 2,127 billion euro every year and will maintain its financial effort on launches. I trust in this future, and I share this trust with you at the end of this dense launch evening. We have taken all the necessary measures to ensure the future of launches, and more generally speaking, to continue the adventure of space and exploration, the attraction of which is so aptly described by poet René Char. Actually, he summarized everything in a sentence. How can we live without any unknown ahead of us? Thank you very much. Long live Ariane, France, and long live the Europe of launches.
We are approaching the end of the first part of our mission. We mentioned at the top of the broadcast that we would be taking a break, and it's coming up in about 5 or 6 minutes or so. Before that, a quick wrap-up of events. If you just joined us, 43 minutes ago, Soyuz lifted off, roughly 43 minutes ago, from French Guiana with the 2 new Galileo satellites 5 and 6 in this mission, which is the first in her FOC, fully operational capability phase.
Yeah, the boosters, second stage and third stage, all perform perfectly, it seems, as did the Frigate upper stage. So the Frigate is still flying. We're waiting now for the second ignition of the Frigate motor.
There will be a third ignition of about 2 minutes to pacify or to empty the upper stage of its fuel before sending it to what we call the cemetery orbit. That comes after our broadcast is over. We won't be seeing it, but we just wanted to mention it because the frigate is reignitable up to 20 times, so we take advantage of that. We're going to go to a replay before we say goodbye. The ballistic phase after this will last 3¼ hours.
Lanceurs sont nominaux.
So thanks for being with us so far. Enjoy the break. We'll see you back here at, 13:07 local time.
Fin du trou de télémesure et acquisition de la télémesure lanceur par la station de Perth en Australie.
it's fine, we've gone through it again.
Tous les systèmes bord fonctionnent nominalement.